we have ABC as a 3-digit number. Then I need that it is divisible by 14. So of course its sum can be 0, 14, 28 and so on. But you can clearly observe that maximum sum of A plus B plus C is 9 plus 9 plus 9, that is 27. So reject all this series ahead of 14, and it can never be 0 and a 3-digit number altogether, because 0 plus 0 means it will be actually just 0, that is a single digit number and not a 3-digit number. So we have a question edited as whose sum of digits is 14. That is the direct question. Now there are 3 methods to solve it. The first method is fixing A, and I can fix A as 1, 2, 3, 4, 5, 6, 7, 8, 9. And then B plus C is sum that is required. So of course sum is total 14. So this one will be 13, here 12 and so on up till here sum will be 5. So if I want B plus C as 13, then what can be possible values that B and C be taking? So it will be 4,9, 5,8 and 6,7. So basically 6 as total outcomes. Similarly, in next case, when I want sum as 12, I can fix it as 3,9, 4,8, 5,7, 6,6. So basically it has total 7 outcomes, because if you reverse this pair 6,6, it will give me same number, whereas other pair like 3, 9 will give me 239 and 293, that are different numbers. So this 3 will give me different numbers, whereas this one will give me single number. So 3 into 2 plus 1 will be 7, and similarly for this one it will be 8, 9, 10, 9, 8, 7, 6. Now the very general approach for such type of questions is you won't be calculating all values at 3, 4, 5, 6 and 8, 9. You will be directly calculating the value at 1, directly calculating value at 9. So you have 6 and 6 here, and then you will just check value at 2 and 8. Okay, so basically you just need to remove 4 values in the given outcome table, and then directly keep adding 1 and from both ends, from up and down, such that you reach center. And note that it is not always necessary that here only a single number 10 or anything else is required at center. It can be 10, 10 from both ends depending on cases. Okay, so let me take another example to explain this one. Suppose I have sum of digits of A plus B plus C to be divisible by 9. Okay, I edited the question to be 9. So basically when I have 9 and I try fixing, I will write it here, A plus B plus C is 9, and I fix A as 1, then 1, 2, 3, 4, 5 simultaneously. So when I fix A as 1, I have B plus C as 8, B plus C as 8. And how can I obtain 8? 0, 8, 1, 7, 2, 6, 3, 5, 4, 4. So total 9 cases. 9 cases. Similarly, when I have B plus C as 0, when A is fixed as 9, okay, A is fixed as 9, I have B plus C as 0. So I have only one case, that is 0, 0. So I have single case in there. Now I have found first and last, and we know that it all differs by single unit. But then too we must check it at this and this one. So if you find this, it will be 2 and this will be 8. Now you are ready to follow the pattern blindly, that is 7, 6, 5, 4, 3. So that is the pattern you followed. Similarly here you followed it blindly. I hope you got this method. And for this, the total sum of outcomes when it is divisible by 14 is 13, 21, 30, 40, 49, 57, and 13 will give me 70. So total 70 outcomes are readily observed. Now also for this case you can directly apply formula n into n plus 1 by 2, that is 9 into 10 by 2. It will be 45. Now I will be diving into second method, that is Bega's method. Now you may complain on hearing this method that it will be including cases like 1400, 1310 and other random stuff that is not required in these values. But the Bega's method too can prove the answer to be same. So the very first approach will be using formula n plus r minus 1 c r minus 1 for a plus b plus c equal to 14. Okay, I will be directly applying this formula for this one because I am here including all cases, that includes this random stuff that is not required. But after that I will be subtracting all this random stuff from this one. So in this case we know that a is greater than equal to 1, b is greater than equal to 0, c is greater than equal to 0. So we know that this method is valid when all things become greater than equal to 0. So I will have a minus 1 plus b plus c equal to 13. I subtracted 1 from both sides. Okay, so this all behave as an integers and all are positive integrals. So I can apply this formula now. So n is what, 13, and r is what, 1 2 3, total 3 integers, different or same, whatever, and 13 plus 3 minus 1 c 3 minus 1, so it will be giving me 15c2, and 15c2 will be 15 into 14 by 2, 105. So I have 105 at the first side. Now I will be subtracting the cases like this one that I have taken unnecessarily into this one. So the very first case might be a greater than equal to 10 and b comma c greater than equal to 0. So when a is greater than equal to 10, b and c will keep arranging themselves accordingly to get 14. So here I have a minus 10 plus b plus c equal to 14 minus 10. I subtracted 10 on both sides. This behaves as an integer whose sum is greater than equal to 0, whose individual value is greater than equal to 0. This is also greater than equal to 0, this 2 and this 2. So now I will be applying Bega's method on this one. So we have 4 plus 3 minus 1 c r minus 1, that will be 62, and 62 will be 15. So 15 is answer for this. Now similarly I will have b greater than equal to 10 comma a greater than equal to 1. Note this a is greater than equal to 1 all time and c greater than equal to 0. So I have a minus 1 plus b minus 10 plus c greater than equal to, I subtracted 11 both sides, so 14 minus 11 will be 3. So basically this one will have 3 plus 3 minus 1 c2, that will be 5c2, 5 into 4 by 2, 20 by 2, 10. So it will be 10. Similarly when c is greater than equal to 10 and a greater than equal to 1 and b greater than equal to 0, so we will have again 10 as answer. Of course you can directly multiply this all value with 2 because these cases are similar type. So we have this as 45, 15 plus 10 plus 10, and then yeah, it is 35 here. So this is 35, and then here checking the answer, we have to subtract 35 cases from it, so it will be 0, 7, 70. This is the same answer as we got in the last case, right? And similarly, let me do it for this one too. So here a plus b plus c is 9, and we know that a is greater than equal to 1. So we have a minus 1 plus b plus c greater than equal to 8. Subtract 1 both sides and apply direct formula n plus r minus 1 c r minus 1, that will be giving me 10c2. 10c2 will be 10 into 9 by 2, 9 5 are 45, so 45 is the answer. That is verified. So these were the two methods. Third method is most widely used, that is multinomial, in such type of problems. So we were given number ABC, that is a 3-digit number, and a plus b plus c is equal to 14 given, and a is greater than equal to 1, b is greater than equal to 0, c is greater than equal to 0, and each of the individual a, b, c are less than equal to 9. A, B, C all are less than equal to 9. So these are the conditions. So looking at the above conditions, we can form our multinomial equation as follows: x plus x square plus dot x to the power 9 into 1 plus x plus dot x to the power 9 whole square, because this same term repeats for c. And in case of a, we cannot write here 1 preceding the x, because a is greater than equal to 1, and hence it cannot be written. If it was 0 written here, then you could definitely write here 1. But for now I am going to write here 1 plus, but also subtracting 1, because it will help me find x raised to 14 coefficient from this whole equation, because it gives me cube of this subtracted from square of this using this all things. So it will be cube of this. Now before writing the same thing again, I will directly use GP formula on this one. So GP formula is 1 minus x to the power n upon 1 minus x, and similarly 1 minus x to the power n upon 1 minus x. It is cube of this whole thing and square of this all. So in this case we can write as 1 minus x to the power 10 cube into 1 minus x to the power minus 3 minus 1 minus x to the power 10 whole square into 1 minus x to the power 10 to the power minus 1 minus x. Now we know that coefficient of expansion of this 1 minus x to the power n is given by 1 plus nx plus n into n minus 1 by 2 factorial x squared dot dot dot. So in order to get x to the power 14 from both of these things, x to the power 14 from this whole as well as this whole, we can have only two cases for each of this term, for this 2 and for this 2. So here two cases will be like, I will take simply 1 from this and x to the power 14 from this, and second case will be, I will be taking x to the power 10 from this and x to the power 4 from this. If I go up till x to the power 20, then it is impossible to get x to the power 40 from here, because this is not having negative power of x, it is actually positive powers of x as per expansion. So solving the above all things, you got 120 as product of x raised to 14 and x raised to 0, and minus 45 as x raised to 4 and x raised to 10 coefficient. And for the next expansions, you similarly got plus 15 and minus 10. So your final answer will be again 70 as per the last time that you got, because this is 75 and this is 5. So 75 minus 5, basically 70 is re-obtained as an answer.